So, welcome to section 2.4. We're going to compare sizes of things like 1/2 to 5/8, and we're going to compare them with number lines. And just as a recap here, recall that numbers are used to represent the amount of some quantity. How many items, how much of something, right? That's what we use numbers for. Okay, so this is part of the reading, but this is worth repeating here. You don't have to take notes on this. You're not responsible. Remember, you're only responsible for like 2.16a. But this is just taking a mile and breaking it into different units, different fractional units. So all we're trying to say here is that 0 miles is the same thing as 0/5. It's the same thing as 0/3, 0/2, or 0/8. So numbers that line up vertically on the number line, like those, are all equal. Even if we replace 1 mile with something else, like feet or whatever, eggs, it's still the same. 0 is 0. So remember, the denominator, which is also we call the unit, represents the name of the part, right? Halves, thirds, whatever. Well, the numerator simply counts out how many you have. It just counts out the parts. While it is possible to have 0 parts of something, it is not possible to have no units of something. So 216 are responsible for. Let's go through what that means. So I'm going to show that 0 over any number except 0 is equal to 0. And any number over 0 is undefined, meaning that it is not a number. Again, provided n does not equal 0. So let's give an example here. Division can be defined by multiplication as their inverse operations. One undoes the other. For example, we say 12 divided by 4 equals 3. Because 3 times 4 equals 12. So that's part of fact families that you probably learned in 3rd or 4th grade. All right, now I'm going to arbitrarily choose 5 for n. However, I can use any non-zero number for this. We say that 0 over 5 equals 0 because 0 times 5 equals 0. Now, does 5 over 0 does not equal 0, because 0 times 0 does not equal 5. So it's really important to distinguish between this, which is 0, and this, which is simply not a number. So hopefully you read 2.17. This is the one you're responsible for, 2.17a. Order the following fractions from largest to smallest. So I'm going to do this with number lines. So I'm going to try to draw a straight line. These are thirds. We have 3/3, so I'm actually making 1 whole here of anything, something. And then these would be ace, and 1 whole has 8 ace. And these here would be fifths, and 1 whole has 5 fifths. So these are all equivalent because they line up vertically on the number line. And we also know that these are all equivalent. So let me make thirds. Try to make them. There's 1/3, 2/3, 3/3. Ace, it would be 1, 2, 3, 4, 5, 6, 7, 8. And fifths, there would be 1, 2, 3, 4, 5. And so we want to know which is the greatest. So the greatest one is, here's 1, let me change colors. Here is 1/3. Here is 1/8. And here is 1/5. And I think it's pretty clear that the largest number, the number that is going to be closest to 1, is this one here. So 1/3 is the largest. 1/3 is greater than, what's the next largest? And if you said 1/5, you would be correct. And then 1/5 is greater than the last one, 1/8. Now this should kind of make sense to you because the bottom numbers, the denominators, the unit, tells you how many parts the whole has been cut into. And so the more parts you cut them into, like 8 versus 3, the smaller each part is. So that is the answer. It should make sense. So we're going to fill in here 2/5, 2/3, and 2/8 of a ton. And then we're going to order them from least to greatest. And just in case, right, that means less than. And that sign there means greater than. So 2/5 is right here. So this is 2/5 of a ton. 2/3 is right here. So that's 2/3 of a ton. And finally 2/8 would be right here. There's 2/8 of a ton. So the smallest number is 2/8. So the next smallest number would be 2/5. And finally, the largest of the numbers is 2/3, which should make some sense to you, right? Thirds, cutting into thirds, you're going to get bigger pieces than cutting into fifths or cutting into eighths. And make sure you read the question, least to greatest. So I'm going to order these from least to greatest as a thought question. Now, one thing you should notice, there's 3 of each kind. This is done on purpose, just to get you to understand. This is the quantity, 3, on each one of these fractions. So the largest number is going to have cut into the fewest amount of pieces. So that's the largest number. The smallest number is going to be cut, and it's going to be right here, into the most amount of pieces. So the smallest number is 3/25. And we say that's less than the next smallest number would be 20th. And finally, the largest number in this group is 3/11. So it should be clear to you that the bigger the denominator, the more pieces it's been cut into, and the smaller each piece is. So when the numerators are all the same, it's pretty easy to tell what's going on here. Okay, so I left 2.18 for you to look at, and we're going to do 2.18a, which is part of your homework. So a container of water. That means one container of water holds 40 gallons on a boat. Make comparisons to the whole container. So here we have the whole container broken into fifths. Here we're going to find the gallons of water. And here we have fifths, fourths, halves, and eighths. Now notice these all line up vertically. So I'm going to go, one container is 40 gallons of water, which equals 5/5, which equals 4/4, 2 halves, and 8/8. They're all 1. And in this case, the whole is the container with 40 gallons of water. So we want to find out these red dashes, how many gallons are in each FIP, because there's 5 of them, right? 1, 2, 3, 4, 5. So we're going to find one FIP first. And we do that by either taking 40 and dividing it by 5, and we get 8. Or we can take 40 and multiply it by 1 FIP, which is an equivalent operation, and we get 8. So 1 FIP is 8, 2 FIPs is double that, which is 16. 3 FIPs is another triple this, or add another 8, 24. And finally 32. So 1 FIP is 8 gallons, and 2 FIPs is 16 gallons, etc. Now we want to find 1 and 1 FIP containers, or 6 FIPs, in terms of how many gallons that would be, which is more than the whole, right? Because 6 FIPs is greater than 1. So we just add another 8, right? So we get 48 gallons. So 6 FIP is 48 gallons and is 1 and 1 FIP of a container. So here we have a box of flour weighs 5 pounds and contains 17 cups. So here's our 1 box of flour, which is equivalent to 5 pounds of flour, which is equivalent to 17 cups of flour. And then these other units are sevenths, halves, and eighths. So these line up vertically, these are all equal. What we're interested in is half of something. So we're going to find these halves. So if you have 1 box of flour, this would be 1/2 of a box of flour, right? If we have 5 pounds of flour, how many pounds would be in 1/2 of that? And if you said 2.5, you would be correct. If you have 17 cups of flour, what would be 1/2 of that? And if you said 8.5, you would be correct. 7/7 is the whole box. What is half of 7/7? If you said 3.5, you would be correct. Of course, 1/2 and eighths would be 4. So we can say that 1/2 of a box of flour equals 2.5 pounds of flour, equals 8.5 cups of flour, equals 3.5 sevenths, 1/2, and 4/8. So the idea here is to be able to find half of something. And even though this is 3.5 sevenths, it may look weird, but it's exactly equal to 1/2. And so is 8.5 seventeenths. Exactly equal to 1/2. So we're going to find, this is part of the same problem, we're going to find half of the following fractions and then use that information and that knowledge to be able to find magnitude. What's bigger than what? So these halves would be 4.5, right? What would this be? How about 7.5? Because 7.5 plus 7.5 is 15. Half of 20 is 10. Half of 11 is 5.5. So these are all equivalent. We could put equal signs between them. So now we want to insert greater than, less than, or equal to make the following statements true. Now I'm going to do one and just put it on pause, and you do the other two and see if you can get these, right? So 1/2 of 5 is 2.5. So 3/5 is greater than half, because they only need 2.5 up here. quantity of 2.5 of those to make half. Half of 13 is 6.5. So this is less than half. This is less than half. This is more than half. So 6/13 is less than 3/5. Let me put it on pause here and try to do these next two. Okay, so these are going to be equal because they're both half of 6 is 3, half of 10 is 5. They're equal. This one, half of 11 is 5.5, but you have 6, so this is more than half. This half of 8 is 4, so this is less than half. So 6/11 is bigger than 3/8. And it's useful to be able to compare these things. Now here's a thought question. Order from least to greatest. So let's see what we can do here. This is exactly 1/2. Half of 12 is 6. So 10/12, 10/20 equals 1/2. 7/12, half of 12 is 6, so that you got 7 of them. That's the quantity, right? So that's greater than 1/2. And 4/9, half of 9 is 4.5, so you only have 4. So this is less than 1/2. So from least to greatest, the smallest one is 4/9 because that's less than half. And the next one would be 10/20 because that's equal to half. And finally, the largest one is 7/12 because that's greater than 1/2. So you can write it like this. So I let you read 22.20, and I'm going to do what's for your homework, 2.20a. And we're going to order these, and it says this time from largest to smallest. So why don't you put it on pause, see if you can handle these, and come back. Okay, so this here is equal to 1. 13/13 is 1. 3/2, that's greater than 1. 5/8 is a little bit more than half, so it's greater than 1/2. It's certainly less than 1. And 16/24, that's also more than 1/2. So these two here, I don't know about right now. But I can tell you the largest one is 3/2. And then the next largest one is 13/13. I'm a little confused about these two, but what I noticed is that 24, 8 is a multiple, 8, 16, 24. I could easily change 5/8 into a new fraction with 24th denominator. And I could do that by multiplying by 3/3, which is 1. And I get 15/24. So 5/8 is equal to 15/24. Now it's simple to compare these. Obviously, 16/24 is larger than 15/24. So it's just sort of a logical reasoning process to go through with these. Well, here's our last example, 2.21a in this section. So they want to order these, I'm now including decimals, from smallest to largest, using less than, greater than, less than, and equal to. So looking down these, I see this one immediately. This is greater than 1. 5/3 would be more than 10/10 because 10/10 equals 1, right? 1 whole. So 5/3 is way up here. So that's the largest number of all these. I hope that's clear. 3/5, I want to turn it into a, see, I don't really care what that is as a decimal because I know it's the largest number. All I'm doing is ordering these. So 3/5, I'm going to turn it into a decimal. To turn it into a decimal, I need a 10 or 100. I can get to 10, right? by multiplying by 2 over 2. So that's 6/10, which is 0.6. So clearly that's the smallest one. That's right here, 0.6. So I got my smallest one, 0.6, and that's going to be less than everything else. Now let's look at 0.7999. Some students think that's 7,999, which it is. It's 7,999 10,000s, or 100,000s, 10,000s. But it's certainly less than 0.8, and I'll show you why. So if I had 0.7999, and I added to it 1/10,000th, I would get 0, 1, 0, 1, 0, 1, 8.8. So this is smaller than 0.8 because I have to add something to it to get 0.8. So really, you kind of look, the first decimal tells you how large it is. The tenths place there. So the next smallest one is 0.7999. Now let's look at 0.8 and compare 0.8 to 0.800 to 0.0800. Well, this one doesn't even have 1/10. So this one is way down here, 0.08, 800ths. So that's even going to be smaller than 0.6. So I got 0.08 here. Now I just need to look at these two. And take a guess, which one do you think is larger? And the answer is they are, well, let's construct this. This is just 8/10. This here is 8/10 plus 0/100ths plus 0,000ths. And I think if you look at it this way, you can see that they're equal. Adding 0 to a number is not going to change it. So that's less than 0.8, which is equal to 0.800, which is less than 5/3. So we'll study decimals more intensely later, but that's a good way to look at it. Okay, so here's what you're going to submit for this assignment. 105, 6, 7, and 8. These are just from exactly the lecture homework video. So all these you will have gone through in the video. And finally we get to the homework here. So these are greater than, less than, or equal to. These you should be able to handle. Number 1 is pretty simple. Number 2 and 3 you should be able to handle. Number 4, yeah, you should be able to handle these. There's no surprises here, nothing that isn't discussed in the lecture video. So good luck and good job.